So in the last video, we introduced the concept of taking a weighted average of isotope masses to find average atomic mass. In this example, we're going to use that same equation to find the atomic mass of a specific isotope. And I have a star here, so you know that means this example is probably important. This example is probably a little bit too long for a quiz, but there will definitely be a problem like this on the Unit 1 exam. So and there's also another practice problem like it on Canvas practice worksheet, but let's jump right in and talk through this problem. I have copper, and I tell you that it has two naturally occurring isotopes. Copper 63 has a mass of this and a relative abundance of this. Use the atomic weight of copper from the periodic table, and we know that those are average atomic masses, so we're going to use our handy-dandy best friend periodic table for this problem, because we need to use the atomic weight of copper from it, along with this information in the problem, to determine the mass of the other copper isotope. So we said we're going to use the equation average atomic mass to help us find the mass of one particular isotope. So anytime I have a word problem, I like to identify the equation I'm going to use to solve it, as well as make myself a little table as to the information that was given. I know I'm dealing with copper. I know my average atomic mass from my periodic table, which you should have in front of you right now. If you don't, go ahead and get it because you'll need it. That periodic table says that the average atomic mass for copper is 63.55 atomic mass units. The mass of my first isotope and its abundance were given to you in the problem. I wasn't given the mass of the second isotope. That's what I'm looking for. I'm going to represent it in my equation up here by the variable x for a second. I did not give you the abundance of the second isotope, but that is easily calculated by the fact that there's only two naturally occurring isotopes. And if one of them is 69.17%, then the total of them must be 100%. So I can subtract 100 from 69.17 to get my percent abundance for the second isotope. So now I have everything I need to solve this problem, which is going to take a little more algebra, but I know you can do it. First thing is for this problem, since my abundances are in percent, I'm going to change them into decimal form. So I take my percent abundances and divide by 100. Now I'm going to start plugging in what I know from the information I was given into the equation for average atomic mass. So I know that my average atomic mass, 63.55, is equal to the sum of my first isotope mass and abundance in decimal form. So this first isotope, which is designated here, it has a mass of 62.936 multiplied by its abundance in decimal form. So that's for the first isotope. Plus, because remember I'm summing, the product of the mass and percent abundance for my second isotope. I don't know what the mass of the second isotope is, so I'm just going to call that X. I do know my percent abundance, or I do know my abundance in decimal form for the second isotope. Calculated it here. So I'm going to go ahead and use this equation to solve for X, the mass of my second isotope. So first things first, you always do what's in parentheses first. So go ahead and multiply 62.936 by 0.6917. And again, I'm not going to be too picky on sig figs here. Technically, this 4 is not significant. I can underline it if I want, but I'm going to bring it along for the ride. So after I multiply these two numbers, I get this equation. I'm going to go ahead and subtract 43.534 from both sides to try and isolate my X. So when I do that, when I subtract 43.534 from both sides, your equation dissolves into this. One more step to solve for x. To get x by itself, I need to divide both sides by 0.3083. And doing that, the 0.3083 will cancel out on the right, leaving me with my x on the right. And so when doing that division, I get a final answer of 64.92. That is the mass of my second isotope. So by using the definition of average atomic mass and doing a little algebra, I was able to find the atomic mass for that isotope. So you should feel comfortable doing a problem very similar to this for the exam. We're going to end this video just by talking about some important examples of isotopes. You need to know about them not just because you're going to be quizzed and tested on them, but because they are very important, particularly in the medical field and in the biotechnology field. There are a lot of isotopes that are radioactive. If you want to learn more about radioactivity, I would encourage you to take Chem 1 and Chem 2 because you talk about nuclear reactions that involve isotopes more. But there are a lot of isotopes that are used in medical applications, in research, also in dating certain rocks like carbon-14 dating or even rocks from the moon. Historians have even used isotopes of strontium to help date and help determine the kinds of diet that prehistoric animals have been exposed to throughout the centuries. So you don't need to know those for the quiz or the exam. I just wanted to highlight to you why we learn about isotopes, aside from the fact that they help build the periodic table, average atomic mass, but isotopes are used quite frequently in various fields.